Pediatric vehicular heat stroke is a medical emergency that occurs when a child, who is often left in the car, experiences increasing temperatures that raise the child's body temp too high, causing the child to overheat and die. We were tasked to design a system to prevent pediatric heat stroke by reminding caretakers of a child in the back seat and to keep the infant from overheating. We decided to tackle this problem by creating two different systems: a preventative system to remind the parents to remove their child from the car, and a medical intervention system to keep the baby from overheating if left in the car. Both of these systems have different requirements. One of the main requirements for the preventative system is that the driver alert that reminds the parent needs to be between 60 and 70 decibels. We also want the total cost to be less than $50. For the medical intervention system, we need a cooling system to decrease the temperature of 80 degrees Fahrenheit inside of a car to 70 degrees Fahrenheit in 15 minutes. We also want the weight of this system to be less than 1 to 2 pounds and the cost to be less than $50. For a preventative system design, we used two ultrasonic distance sensors, one to determine if the door was open or shut, and one to determine if there was anything in the back seat, such as a child in the car seat. We also used a piezo, which is a sound maker, and an Arduino. The ultrasonic sensor that reads if the door is open or shut would detect if a door was open greater than 12 inches, which would occur when a parent was exiting the car. The ultrasonic distance sensor that read if there was anything in the back seat would determine if there was anything within 24 inches. If both of those requirements were met, then the Arduino would trigger a lullaby to play on the piezo, which would act as a reminder for the parent to get the child out of the car. For our medical intervention design, we used a fan, an LED, and a temperature sensor, all connected by an Arduino. The temperature sensor reads ambient temperature inside of the car, and if the temperature is greater than 80 degrees Fahrenheit, it turns on the fan and the LED. The fan and the LED stay on until the temperature sensor reads a temperature lower than 70 degrees Fahrenheit when the fan and the LED turn off. We also compiled this medical intervention system with a cooling system, which aims to cool down the overall internal temperature of the car. We used an evaporative cooler, which uses water evaporation to cool down the ambient temperature, and a thermoelectric cooler, which uses conduction and a Peltier to create a heat differential in heat sinks. We tested a preventative system by placing the system in the car. The lullaby alarm initiated when the driver's side door was open greater than 12 inches, and when the car seat was placed in the back of the car within 24 inches from the ultrasonic distance sensor. We also detected the sound level of the piezo, and it was determined that the level reached 60 decibels, which met our requirements. For the medical intervention system, we used a box to mimic the enclosed car and a heater to mimic the sun's effect on the car, and we tested the medical intervention system and the cooling system inside of that mimicked box. The fan and the LED turned on when the temperature was above 80 degrees Fahrenheit and turned off when the temperature was below 70 degrees Fahrenheit. However, when the cooling systems were added, they did not cool down the system adequately. The system would not cool down below 70 degrees Fahrenheit, and it wouldn't cool down within 20 minutes. We also performed a cost analysis on the preventative system and medical intervention system. Both systems were less than $50, which met our requirements. The weight of the medical intervention system was also 0.27 pounds, which also met the requirement of less than 1 to 2 pounds. The preventative system successfully met all of its design requirements. The medical intervention system met most of its design requirements, except for the specifications for the cooling subsystem.